Math 2, 6-3, proving similar triangles on page 358. Thank you for not talking. Okay, so at the bottom here, this should kind of look familiar. Okay, first of all, this is angle-angle similarity. Okay, postulate. So notice how it says AA, and then it has the squiggly line that stands for similar. Okay, so if you have two angles that are the same in a triangle, first of all, that lets you know for sure that the third angle will have to be the same, right? If two are the same, then the third one has to be the same. Now, could you write angle, angle, angle? You could, but basically you don't need three angles. You only need two angles in order to prove similarity. So that's all this is saying, is that if you have two angles that are similar, the triangles are similar. Two angles that are congruent, the triangles are similar. There we go. Okay, questions? Okay, and it says it right there. All right, moving on to page 359. We're going to put that theorem into use. Okay, or postulate. If I can talk correctly today at some point. Okay, page 359. So notice here, this angle is how much right here? 90. This one is 90. Now this is saying you have a 39 degree and this is saying a 51 degree. Those are not the same. What can I do to figure out what the missing angle is? Okay, so if I have 90 plus 39, what does that equal? 129. And then 180 minus 129. And I get 51. So that means that this angle right here is 51, which means that this angle right here is 39. Okay, so are the triangles similar? Yes. Yes. So I'm going to write this out. Triangles are similar by angle, angle, similarity. So we just write that as AA similarity. Now, there are three angles that are equal or congruent there, but we only need two. Okay, moving on. So on page 359, the practice. Okay, what happens, what do these little arrows mean? Parallel lines. Okay, and this is this line like FH that's going through there. That's called a what? Do you guys remember? Transversal is correct. So what does that tell you about like this angle and this angle? They are equal. Good, they're congruent. So this angle is equal to this angle. Is there anything else that I know? These are congruent by what? By vertical angles. So are these triangles similar? Yes. So we need on this one, they want us to write the similarity statement and then the postulate we used. Okay, so how would I write? Well, you start with one triangle. So if I go triangle FHG, and then we write our similarity, little line, and then what do I write the other triangle as? F matches with K, and then H, and then J. And we were able to prove similarity by angle, angle, similarity. Okay, do we know right now if number 2, if they're similar? No. We have to figure out what the missing angles are, right? Because right now they only have how many angles similar? 1. Okay, so what are we going to do? Okay, 25 plus 35 equals how much? And then what would I do? 180 minus 60 makes 120. So are these similar?
No.
No. So we can just put not similar. Angles are not the same. Questions? Okay, can I change this? Okay, move to page 360. There are two other similarity theorems here. Okay, so one of them, if you notice here, is side angle side similarity. Okay, we also have side 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 similarity. Okay, so side angle side means you need two similar sides and a similar angle, right? Okay, side, 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 three similar sides. Now, when we're talking about the sides, do they have to be the same number? No, they just have to be the same ratio, right? Yes? But the angles, if you're doing angles, the angles have to be the same. Okay, are we ready to see what's going on? Okay, so on page 361. Okay, when I look at A, do you see any angles there? No. So this one, if they are similar, it would have to be by side, side, side similarity. Okay, but we have to make sure that the sides are the same ratios. Okay, so on these, sometimes when they don't tell you the similarity statements, you have to look at like small versus big sides, like your smallest, your medium, your large. Does that make sense what I'm saying? So in this case, 6 and 6, both of those are smaller than 9. And so over here, 8 and 8, those are both smaller than 12. So we would write this as 6 over 8. And what does 6 over 8 reduce to? 3/4. Do I need to do the other 6 over 8? No, because it's the same thing, right? And then since I'm starting with the 6s, I have to start with the 9. And we put 9 over 12. And does that reduce to 3/4? So are these similar?
Yes.
Yes. So we have to write our triangle congruent statement, or similarity statement, sorry. So triangle ABC is similar to triangle, and where would I start? E, F, G. And how did I know this? What similarity theorem did I use? Side, side, side similarity. There were no angles in there, right? Do we have questions? Okay, on this next one, do we see any angles that they both have? What angle do they both share? That 90-degree angle. So could I maybe end up using side angle side? Yes. Okay. So if you need to, you might want to separate these. So one of your triangles is like this, the smaller one, that's 90, and one side is 6 and one side is 8. Do we agree? Now the big triangle, this side is 12 and this side is 16. Okay, if you were to reduce these, 6 over 12 reduces to 1/2, and 8 over 16 also reduces to 1/2. So do they have similar sides? Yes. Okay, so I'm going to give you a chance to try it on your own. Write down the triangle congruence. Okay, so if I have triangle, and did you write the letters here on this one if you went back? This is a W and an A and an L. And on this triangle, it's A, E, C. Okay, so if we have triangle AEC, my big one is similar to what triangle? How do we write it? Good. AWL. And how did we know that? Side, angle, side, similarity. Okay, and I forgot to write up here. What was this ratio? 3 to 4, good, because we did smaller to bigger, right? Okay, what about this one? What is it going to be? 2 to 1 because I started with the big one, right? 2 to 1. Okay. Questions? Okay, moving on. Turn to page 361. Okay, so I'm going to give you a chance to check this one. So on number 3, if they're similar, give me a 1 on your fingers. If they're not similar, give me a 2. So go ahead and see if you can figure it out. Good, good. Good, 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 good. You got it, got it, got it. Good. Okay, so most of you said on number 3 they are not similar. So how did you figure that out? That is true. If you just look at it, 1 is 6 over 6, and then 1 is 8 over 10. So this gave us a 1, and this one obviously is not 1, right? If you were to reduce that, that's 4 over 5. So we are just going to put not similar. And how are they not similar? They don't have the same, you could put, yep, not the same ratio. Okay, same thing on number 4. If they're similar, give me a 1. If they're not similar, give me a 2. No. Good. Good, 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 good. No. Good, good. Nope. Yes. Good, good. Okay, so this one, good, is also not similar. So let's check on the ratios. So my smallest number on this is 22. What's my smallest number on the other triangle? 32. And we can reduce that by 2, and I get what? 11 over 16. Okay, so then the next largest side would be 30 over 45. We can divide by 5 to the top and the bottom, right? And I get 6 over 9, and you can reduce that again and get 2 over 3. Are those the same? No. Nope. So that's why they are not similar, and we can put not the same ratio. Okay, lesson check, page 365, number 9. Okay, number 1, or not number 1, number 9. Check that one out. It says, are the triangles similar? If yes, write a similarity statement and explain how you know they are similar. So give me a 1 if they're similar, a 2 if they are not similar. Good, 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 good. All right, so the correct answer is they are similar. Okay, so what did you do to figure out if they are similar? Good, and first of all, these are vertical angles, so we know that's 35, right? And so if you went 45 plus 35, you added those together and you got 80. And then 180 minus 80 gave you 100. And so we have 2 similar angles, correct? 2 congruent angles. And so my answer would be yes. And then what, so if we do our triangles, if I start over here, if I go AEZ, that is similar to triangle, what? REB. Okay? And then they asked us to tell them how we knew this. And we did all this by which theorem? Angle, angle, similarity. Okay? All right, 10. Notice on this one, do they talk about any angles? No. So the only theorem that we could end up using would be side, 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 right? Okay, so you need to check if they're the same ratios. Do they look like they are the same ratios? So you can give me a 1 or a 2, depending on what you think. Correct. Nope, nope. Nope, nope. 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 Yes. Nope. No. Yes, yes, no. Yes. Yes. Okay. All right, so they are similar. So let's look. What is the smallest side? 2. And what's the smallest side on the other one? 3. Okay. What's the next side that's biggest? 3 over 4.5. Now, because you have a decimal fraction, you can't really tell. So if I were to move this decimal once, I could move this one once, and I end up with 30 over 45. And we can reduce that by 15, and we get 2 over 3. See how that's the same? And then our largest sides are 4 over 6, and those also reduce to 2 over 3. So do you see how I deal with the decimal thing? Okay, so this one is yes. And so if we go ABC, triangle ABC is similar to triangle what? FED. Good. Very good. Side, side, side similarity. Okay, last one, number 11. So remember 1 for similar, 2 for not similar. Good. Good. Nope. Good. Nope. Aaron, no. The other Aaron. Good. Good. Madison, no. Yes. Yes. There you go. Correct. Oh, that. Oh, okay. Good. Good. Okay, so these are similar. We can see that they have an angle that's similar, and so we need side, angle, and side for this theorem. And so see which number is the smallest between 12 and 16. Yeah, good, you guys are smart. And so on the other one, it would be 15 would be the smallest, and we can divide those by 3, which would make 4 over 5, and then the next angle we'd have 16 over 20, and that can reduce by, and we get 4 over 5. So do they have side angle side similarity? Yes. So my answer is yes. And so over here, if we write that as triangle, okay, BEF is similar to triangle what? A, and you said G, and then U, right? Okay. All right, and that was by what? Side angle side similarity. Okay, questions?